All right, ladies and gentlemen, in previous lessons, we've done quite a bit of work just like translating text about a function into mathematical notation, because that helps us make meaning of what the text is saying, right? So for example, when we see f of x is increasing, the way we think about that, right, is we want f prime of x to be greater than 0. So what we're going to do in this lesson is take all of these ideas and apply them just to our accumulation functions. So for example, our umbrella factory function that we studied before, right? You have notes on this. It would be a great use of your time actually to just try to fill this out from memory and make sure you've built all of these connections. I'm going to fill this out for you, so you'll have the solutions here in a second. All right, so here are our descriptors, right? So for example, f of x is decreasing means my derivative is negative. F of x is concave down means my second derivative is negative. And then of course our maximums, minimums, and our points of inflection, we're looking for sign changes in all of those things. If you feel like you have a strong understanding of this and you have a strong understanding of our previous work, this module will hopefully come pretty easily to you. So we're going to consider our accumulation function about our umbrella factory just as an example that is familiar to us. So recall our function from the last video was f of x is equal to the integral from 0 to x of g of t dt. And then here we're going to take the derivative of f of x, so f prime of x is equal to, well, just g of x, right? Because our first derivative, our derivative, and our integral kind of cancel out. And then, well, by that logic, f prime prime of x would be equal to g prime of x. So notice we're kind of like one level back of where we would be if we had started with just like a normal f of x function instead of an accumulation function. So my f prime of x is plain old g, and then f double prime is just g prime. So the question here, where is f of x increasing? So f of x is our accumulation function on the interval from 0 to 14. Well, the answer here is really everywhere, right? Because everywhere I go, my rate was positive, and we talked about that in the last video. So our justification here, well, we would say, first of all, that f is increasing for all of the x on our interval, and our justification would be since, well, f prime of x is equal to g of x, and g of x is greater than 0 for all those x's, right? So g of x is our graph of the derivative of f, f being the area under the curve of the graph at each x, right? So notice this is important, right, that we note that we recognize that f prime is equal to g, because otherwise our reasoning isn't quite clear if we just say g of x greater than 0. It doesn't connect back to f. And then we're asked for a point of inflection. So again, point of inflection I can annotate means we want f prime prime, change signs. But we have this extra step now of being like, okay, that means we want g prime to change signs, which means g goes from increasing to decreasing, or vice versa. So that, of course, is at the point x equals 10. So our solution would be x equals 10. And our justification is basically this logic. So we have g of x equal to f prime of x again. And then we say g of x changes from increasing to decreasing. By the way, we can add that up here, right? So a point of inflection, we have f prime prime of x changing signs. Where that would show up on f prime of x is a change from increasing to decreasing or decreasing to increasing. Okay, so notice our analysis is basically the same on these things, with the small added complication that we're starting with an integral. The next thing we're going to do is we're going to fill out a second table now, and notice now f of x is an accumulation function. So it's going to look very similar to our first table, just a little bit different because we're going to be kind of one level back, and then we'll do a little algebraic example, and then we'll also do a graphical example, so give you a lot of references to work off of. So again, here I'm going to give you one example. F of x increasing would be g of x being positive, right? And notice I note here f prime of x is equal to g of x is positive. Or you could be like f prime of x is equal to g of x, and you could say g prime of x greater than 0. You don't want to be like equal to greater than though, because then you get a mathematical sentence that doesn't make a whole lot of sense. So you'd write that separately. But notice it includes two pieces now. So again, fill out the table. This time I would say use pencil so that you can change any errors after you check your work. Okay, so here is our sort of reference that's going to guide us through this lesson, and then we're going to consider this example. So here we have this accumulation function, f of x, and determine all intervals on which f is concave up. So notice we have no g here, but we have a g without it being called g. So the way I would approach this, just so I don't get confused, I'm going to write my work out very nicely. I'm still going to annotate. I'm going to be like f prime prime is greater than 0. And then I'm going to be like f prime of x is going to be negative x to the 5th plus 30x to the 3rd. Okay, so it's very important that you keep your work organized, otherwise you're going to make lots of mistakes. So I labeled f prime of x, and then I just kind of rewrote the function with x's in it. And then I want to consider my second derivative, so f prime prime of x. And then I'm going to use power rule, right? So I didn't change the function before when I took my first derivative because I just canceled out the integral. But here I'll be like negative 5x to the 4th plus 90x to the 3rd, x squared. I almost made a mistake there. And then I'm going to carry on, right? I'm going to be like, I'm going to set my second derivative equal to 0 because I'm looking for a sign change, and those can only occur at 0. I'm going to factor out my negative 5x squared. And then this is one of those kind of ugly ones where I'm like, okay, 5x squared, and I say x plus the square root of 18. I'm going to use a difference of squares, even though 18 is not a nice square number. And then I'm going to make a sign chart. And when I plug in these values, I could use negative 1 and 1 here. I get positive, positive in the middle, and then negative, negative on the end. So f is concave up everywhere where f double prime is positive. So there we go. And for now, you should be thinking like, okay, this is something we definitely have done before, with this added step of considering what to do with the integral when I take a derivative. Okay, the last thing we're going to consider is something graphical in nature. So we have this function f shown below, and it says g is an antiderivative of f such that g of 4 equals negative 5. That's a little bit tricky written that way, but really what this means is if f is the derivative of g, I can write g down as negative 5 plus the integral from 4 to x of f of t. Okay, and that of course means that g prime of x is equal to f of x. By the way, don't stress if you're not entirely sure how I translated this into this, as that is not a huge part of what we're focusing on for this lesson. We want the minimum value of g. So the minimum value of g, here I know that g prime of x is equal to f of x, so we want f rather to go from negative to positive. Okay, so there's one critical value that I'm going to consider here, right? That's x equals 6. And I'm going to, again, make a table, right? And I'm going to consider my critical values. And you've now done this before, right? So my critical values are going to be my endpoints. And my function here is going to be the integral from 4 to negative 9. And the values here I get are negative 18, negative 9, and 0. So my minimum value here by the candidates test, right, would be negative 18. Okay. And if you're unsure how I got that, I'm just using my area formulas. Well, actually, I'm just copying from Delta Math, full disclosure, but they did it this way. And notice we have one integral that's in the incorrect order, right? So I would negate this one and add. So feel free to annotate your graph if that's helpful to you.